Sounds good. Yeah. Accessibility zoom is gonna be my like downfall. All right. How is everyone doing? Nice. So today we're kind of taking a bit of a sidestep from the stuff that we've been doing. We're going to be moving away. I know you guys have been doing React all week, some socket stuff, and we're going to be looking back at just learning more about JavaScript as a language, and we're going to be looking at JavaScript prototypes. I would say this is not necessarily the most fundamental thing that you need to know, but it is really nice to kind of know a deeper understanding of JavaScript, and it can be kind of interesting. And depending on how or what you get into as a developer, you may end up using a lot of prototypes in the future. But for web development, as it is in this boot camp, maybe not the most crucial thing. But I think it'll be interesting to learn nonetheless. So just an overview of what we're going to cover. We're going to look kind of at objects. We're going to review what we know about them and some extra things that we may not already know. We're going to have a brief look at OOP, which stands for Object-Oriented Programming. You guys will cover this more in detail, I think, next week, but we're just going to introduce it here. And then we're going to look at prototypes and inheritance. So starting off, this is what we already know about objects. So JavaScript objects are data structures, and they store information in key value pairs. Like we have here, key name and value. What we may not know is that when we're declaring an object like this, the same way that we would have done 100 times by now, This is called an object literal. So that's an object literal. If I look at this, we can see my little object here. Defining an object this way, it creates a single object or one instance of an object. We can also add functions as object members, and when an object has a function, it's called the object's behavior. The object is said to have behavior. So if I say literal dot sum function, and this is going to equal a function, maybe where I just console log something. Oh boy. And now if I do literal dot sum function, we get that console log. This is something we've seen a lot. After we define an object, we can definitely add properties after the fact. So although my literal up here only had this one key value pair, I created it, but then I've added another property to it. I can add as many properties as I want. That's something we're probably familiar with. But something we may not have done so much is we can also remove properties after the fact. So if I use the delete keyword and I go literal dot key name, and then if we just look at literal now, our object, we can see it no longer has the key name and value property, or this key value pair at least. So a nice little thing we can do to kind of alter our objects after the fact. This is the primary and probably only way that we've been making objects, but there's also other ways of making objects. And the main motivation behind making objects in another way, if I have this one object here, and maybe I need to make multiple instances of this object, I need a lot of similar objects. To make another one of this like literal thing, I'm just going to have to go like literal 2 equals, and I'm going to have to define it. I'm going to have to say like key name, and maybe now this is like value 2. I'm going to have to add some function and everything else. This might not be so bad with my little object here, but if we're having bigger objects that have a lot of key value properties, I'm not going to want to be rewriting this every time I want to make a new object. Have you guys encountered any ways of solving these problems so far? Has anyone done anything interesting in terms of, I have an object that has 5 key value properties, and I want to duplicate it and have a second one? Has anyone done any hacks on that? Yeah. Yeah. So classes are one way. Sorry? Cool. Yeah, in the computer science week, you would have looked at classes. So classes is one way of kind of accomplishing this. Although in JavaScript itself, classes are kind of an afterthought to JavaScript. The fundamental or the original, like the OG JavaScript is like objects and something called prototypes that can accomplish pretty much the same set of things that classes can do. And in JavaScript, classes are actually built on top of objects and prototypes and things. But there's also some like maybe kind of like hacky ways of like duplicating this. Like if I want to create a literal 3, I could say, it's like I could do like json.parse and then json dot stringify my like original object, literal 1. So I'm taking it, I'm converting my object into a string, I'm popping it into parse, which is taking it back to an object. So I'm essentially duplicating it, and because we know in JavaScript we have variables by reference and variables by value, and objects are all by reference. So if I just said literal 3 equals literal 2, they're both going to be pointing at the same thing, whereas this is actually duplicating it. So this is, like I said, kind of a hacky way of doing it. There's like much better ways of getting multiple objects. The first we're going to look at is a factory. So this is a building in StarCraft called a factory, and it produces a bunch of different like units in the game. So I thought that's how we're going to build all our stuff, is based on StarCraft today. So a factory allows us to make multiple objects. It is essentially just a function that returns an object. This is an example of one. So as you can see, it's just a function. It takes in 2 parameters, and it's returning a specific object. Inside this object that it returns, inside the object that it returns, we can use the parameters. So model is set to model, year is set to year. This allows us to define our object in one place and make many copies of it. So we go in here. So our factory can create Thors, a unit in StarCraft, and when we create a Thor, we're just going to console log Thor is here, and then we have to return an object. So any factory, we're going to be returning something, and our object will have our attack and our speed, and then we'll have a function. And so now, if I want to create one Thor, and I give it some parameters, my factory, prints out my little console log here, but I also have this object now. And I see that the object has my properties attack, speed, and javelin missile as a function. And then if I want to create another one, this one, different properties, I now have my second Thor. This is much cleaner, much easier to make multiple versions of a single object. We can also make another one. Our factories also create Hellions. And I don't know what they say. I'm ready. And this is another kind of shortened syntax that we've probably seen. Instead of writing key and value, if they're going to be the same name, I can just stick to the single attack, and it will know that I'm going to name it attack, and the value I'm storing is looking for a variable called attack. For speed, I can do the same thing. And then also for functions, I can just declare them right in line. So these guys have flamethrower. So same thing. Oh yeah, I gotta refresh this. Sorry? Oh. And we have this guy. So one way of making multiple objects. The other way is a constructor function. So a constructor function essentially does the same thing. but its pattern is a little different. So the creation of a constructor looks like this. So we're going to use Pascal notation instead of the normal camel case notation that we've been using for variables and things like that. That just means the first letter is uppercase and every subsequent word is also uppercase. Not mandatory, but it's kind of the style for both constructors and say classes. And then we're using this throughout this. I know this is everyone's favorite keyword because it always makes so much sense. But so we use this, and we see that to whatever this is, we're adding properties. So for this, we're adding a property model. This, we're adding a property year. This, we're adding a property start, which is a function. So that doesn't really make much sense on its own. And it kind of doesn't do anything unless we introduce this new keyword new. To use this constructor, I have to go, car initializing my variable, and I have to use new with my constructor, passing it the parameters. So new does a couple things for us. When you call a function with new, it creates an empty object. So it creates a new empty object, and then it sets the context of the function to the empty object. So what that means, if I call any function with new, if this is used inside of that function, this will refer to the empty object. So we have an empty object, and then when we're running this function, this is the empty object. This is the empty object. So to the empty object, we're adding properties model, year, and start. And then the last thing it does is it implicitly returns this from the function. So we create an empty object. When this function is run, that's what this is set to. And then when the function completes, it returns that empty, well, now initialized object to whatever variable we have here. So we're going to make a constructor here. This is a constructor. And our constructor is going to be a command center. So command centers are some buildings in StarCraft, and you have to place them in a certain location. So we're going to say this.location equals the location that we place it. And this dot, it can make units called SCBs, and it's going to be a function. So now I have this constructor. If I call this constructor as it's just as a function, whoa. Oh, yeah. So the function, that's really weird. So it's changing my browser for some reason. Test. Okay, sorry, we'll get this fixed in 1 second. You see, if I had the nice accessibility zoom, it's changing my path when I do that, and I'm not sure exactly why. So then when I run it again, it's undefined. I think it's taking issue with the capital. Okay, for now, we're just going to do it in here. So we have this function, and if I run it itself, and if I nice. Oh. Okay, so we see that if I run without the new keyword, I'm getting this not allowed to load local resource. That won't happen in normal script. It'll just run this function and not have any context. I think what's happening here is because I'm running it in the browser, this without a context refers to like the global object, and that's like doing something weird. But I guess the point is, in order for this constructor to be useful, we have to run it with the new keyword. And running, command center and creating a new one, I create this new object, and I have my properties in there. And I can do, I named it poorly, but I can run this guy. You see that the function's running. The other thing that looks a little bit different, and we'll get into this in a second, is when I inspect the object in this developer tools thing, it's not just showing a plain object, it's giving this information behind it. So it's saying this is an object, and it's almost looking like it's giving you a type, saying like command center of this type of thing. So this is our first look at what prototypes is going to be. Still want to get this to work. That doesn't matter. Okay. So we look at constructors. We have this pattern, and we have to use a new keyword. The next thing we're going to look at is secret object properties. So we've seen all the properties that we create when we, make that variable. So we see this stuff right here, but there's also some extra properties that are built into JavaScript that are innate to all objects. So if I click on this little arrow thing here, we get a drop down and we see an extra property that this object has called proto. Oh. And so proto is an object itself. If I click on this little arrow again, it's going to show me the proto object. So proto has a bunch of properties. Some of them look like they're functions. Constructor is an object, but some of them look like functions. Has own property, is prototype of, all of these things. Well, constructor is also a function. But this isn't something that we normally see when we're like console logging our objects or we're looking at them normally. Sorry? Yeah. So we can look at that. Let's go test.toString. Yeah, so we can see here that we get this object toString. So we're not the most helpful thing, but yeah, there's a bunch of built-in functions to it, but the key thing here is that proto is an object. So what is this object, and why does this object have a bunch of things in it? So the proto property, all objects have a parent or prototype, which is an object in memory that that object inherits from. The top of the prototype tree is the root prototype that all objects inherit from, and this is just object.prototype. So if we look here, this object, its prototype is the root object.prototype. Because we've done nothing fancy. If we just create the object itself, our hierarchy of inheritance is just going to be the thing we created and then the root object prototype, which has all of this stuff in it. These built-in JavaScript objects. Just going to look for a marker. Oh, nice. Is there one? So we have hierarchy, and at the very top of our prototype thing, this is like our root prototype. And this is an object that has a bunch of like properties in it. Any object we make just by itself. So this is just another object. It's going to inherit, or it's going to be a prototype of this root. So this is any object literal, any function made at the basic level will be one step below, and you can see that from looking and breaking the object down here. We have one prototype, and because it has all of these built-in functions, we know that it's the root prototype. In this case, yeah. So we're going to look at it, but what eventually happens is we can get a larger hierarchy. So I can have an object whose prototype is another object whose prototype maybe is the root prototype. But we'll get more into that. So when we have an object that inherits from another object, or that has a prototype of another object, we can say that the properties in this guy, in the instance or in the child are instance members. So the property or methods that are stored in the specific instance of an object. If we use things like object.keys or so object being the JavaScript keyword for objects representing that object, and then this second one, obj, being your instance of the object. Either of these will return all the instance members. But you can also access the prototype members. So any prototype that an object has, the properties or methods that are stored in the object's prototypes. Because the child prototype inherits from the parent prototype, it has access to all of these. So in our case, our test object here, we only have one instance member, but its property or prototype members, all of these, we can still use, as we saw here. We use test.toString, and it returns something that was accessible. And to loop through these prototype members, if we do for and we do key in object, that's looking through both instance members and prototype members. When accessing a property, a method walks up the chain of inheritance to see if that object has it. So first check locally in its instance members. It'll say, do I have a property of .toString? No. And then it'll look in its immediate prototype, and it'll say, does that have a property of .toString? It does, so it'll run that one. So the main thing where this becomes kind of relevant is that objects created by the same constructor will have the same prototype. So when I created this object, I just used object literal syntax, and we just had it having the root prototype. But if I create an object with a constructor, it will have a specific prototype specific to that constructor. So, man, we got to do everything in here. Maybe if I... So we had command center 1. Heck. Okay. So if we look at this object that we just created with our constructor, we see it has this beforehand. So that's kind of telling us what constructor made this. And if we look at the kind of like extra properties of this object, we have proto here. And if we look in proto, it doesn't look the same prototype that we saw for the root prototype. It has two things. It has a constructor, and it has a prototype itself. So the constructor is the command center function that we use, or the command center constructor that we use to create it. And its prototype is now the root prototype. So we have a root prototype, and then if we are creating something with a constructor, we get a constructor prototype. And then anything we create from that, this is like an instance of the object. So just innately how JavaScript works, any constructor we make, if we're making an object with that constructor, it's going to inherit from a specific object in memory, which is a representation of this set of objects, the constructor prototype, which will then inherit from the root prototype as we have it right now. So we have this initial command center that we had. We saw that it's inheriting from the command center prototype. And if I make a second one, you can see that it also was built with the command center constructor, and its prototype is that command center prototype. So the other hidden property that we've been kind of like skimming over now is this constructor property. It's a property of every prototype that references the constructor that was used to create it. If no specific constructor was used, it will be the built-in object constructor function. So this first prototype that we have here, its constructor is the command center prototype, and then this prototype's prototype, which is the root prototype, its constructor is the default object constructor because it doesn't have a specific constructor that it was made in. Kind of an aside that's not super important right now, but in JavaScript we know that functions and arrays are also in their own way an object. And so if we make a function or an array, their constructor is the default function constructor and array constructor. So I said we're just briefly going to mention about object-oriented programming. So object-oriented programming, JavaScript itself is not a traditional object-oriented programming language. The overall concept of object-oriented programming is that we want to group related things together as properties and methods of an object. So classes is the traditional or most straightforward way that we see object-oriented programming. And you've had a little bit of exposure to that. But the benefit of classes is that we have these kind of three things: abstraction, inheritance, and polymorphism. Abstraction is the idea that I can make a class, it can have a set of properties and methods, and then someone else can use that class to its full functionality without knowing exactly how I wrote it. I could have really complex function in there, and all they need to know is that you can use my class name and access this function inside of it, and it'll do, what it should. Inheritance. So this is kind of the big theme or the big reason for prototyping, and one of the main things of object-oriented programming. We're seeing kind of an example of inheritance here, but in the strict object-oriented programming side of things, the idea of inheritance is that we can make a class, say a car class, and then we can make a more specific class, like a RAV4, and that class can inherit from the car class, meaning it'll do everything that a car does, but we can add additional things. Again, I'm really rushing through these, so don't worry. I just wanted to get a brief understanding of this when we're talking about prototypes and stuff. The last one, polymorphism, that's the idea that from a single source, we can create many different versions. So from this single constructor, we can create many different command centers. In classes, polymorphism means like from a single class, we can create many different instances of that class, and each instance of that class can be kind of unique in its own way, distinguishing itself from the other classes. So you can accomplish these main things in JavaScript, but it's originally not through classes, it's through prototypes. So now we're just going to look more specifically at inheritance. So if all objects inherit from the constructor's prototype, there's a pattern that we can do to really take advantage of that. And that pattern is to create a constructor, define that constructor's prototype how we want. So this is just some example syntax. And then have all the instances of that constructor inherit the prototype members. So let's look at what that actually is. So right now we have our base object. It's a command center. What if we also want to have a is it planetary fortress or planetary defense? Fortress? Okay, good. So we also want to have a planetary fortress, and it's going to have all of these same things as a command center, but now it has a couple extra things. It can do scans. And can also do like mule drops. I don't know what they. So right now we have two constructors. They are completely detached from each other. If I create one of these, it will just have two. It will just have the two properties we see there. So if I go we see that it was made with this constructor, but we only have the two properties, kind of as we would expect. But what we can do, now that this constructor is created, we know that all constructors, any object made by them, will share the same prototype. So this, although it has nothing to do with a command center right now, it does have a unique prototype. And what we can do is we can overwrite this prototype. So I can say for all planetary fortresses, I'm going to access the prototype, and I'm going to set that to something else. And I can go object.create, which I'm making a specific object, and I want it to be a command center. So all I'm saying here is this constructor has a prototype by default. I want to take that prototype and I want to reassign it. I'm using object.create. So I'm creating a new object, and object create takes one parameter, and that is a prototype of the type of object that you want to create. So I'm saying change the current planetary fortress prototype to a command center object. So before we do this, we can actually also go so I'm accessing just the prototype object, and we can see it's the same. The prototype here has this constructor and a proto, and when we look directly at the planetary fortress prototype itself, the constructor, we see that it has a constructor and a prototype. If we were to look at these in memory, they would be the exact same object. They're not like duplicates, they're pointing to the exact same thing. So any specific object will have the constructor's prototype exactly. But if I save this, And I now make a new planetary fortress. And we look at this, we can see that it has our two functions, orbital scan and mule drops. But then in the prototype, which is a command center, prototype. So we have, our prototype is now command center type. We're not getting these two properties, but what we can do, they're in here somewhere. Maybe what we can do more straightforward is, instead of, because this will wrap it in another layer, we can just say, let's just have it be the same prototype. All right. So this is one way of doing it. We have our command center and we have our planetary fortress, but we can also add properties onto this prototype itself. So we built it saying that our command center is of type, or our planetary fortress is of type command center, and it also now has a couple or one property in the prototype itself. So if we go planetary fortress dot test, we see it's hello. Project numbers. So why is this useful? One, we don't have to repeat code. So if we have one object that is going to use something similar to another object, we're not having to rewrite all those properties in a second object. We have a central source for changes. If we want to update the object's property and we have like 4 or 5 objects that are all similar, we have to go into each of those objects, change the property. Whereas if we're using inheritance and they're inheriting from one another or they're inheriting from a single source, we can just change the source's properties and that'll update the rest of them. And it lets us use polymorphism. So polymorphism, again, is we can have many forms of the same method or many forms of the same thing. I'll show you in a second how we can have many forms of the same method, but we'll leave that for now. The other thing that we can do is it helps us with being efficient with our memory. So every instance of an object normally stores all the properties and methods in memory. If you add a new method, however, only to the prototype, it will only be stored in memory once for all instances of that object. So we have one planetary fortress here. If we create a second one, and we look at this guy, it also has that hello. And the thing is, now we have the pattern of our one constructor, and we have 2 instances of it. Both of these right now store our 2 functions in there. So we have a function and a function in their memory. So we're taking up like this many spaces. But that one variable that we have here, that test thing, is stored once in the prototype. If we had put it in the instance itself, like in where we defined it, we would have 2 versions of it, one here and one here. And if we had 100 instances, we would have 100 cases of that variable. But if we move it to our constructor only, then we just have the single instance of it. For variables, that's not super handy maybe, because variables are usually custom to each object. But for functions, which would be the same across all of these, if we move it to the constructor itself, it really saves us in memory, especially if we were making like tons and tons of these objects. We're going to break for 15 minutes, and then we come back. I'm going to go through kind of like the pattern of making an object with constructor inheritance a bit more thoroughly in an example. What? Oh, yeah. What? Yeah. Yeah. Just like notes for myself. Yeah.
Are we able to
Yeah. That's the second half. I'm just gonna play and I'll be like, oh, you guys are still here.
start?
Can you see the board, or should I bring it like kind of like yeah? Thing is, these camera angles are like garbage. Yeah. Like barely. I think I'm just gonna not bother with the camera because you can't even see the writing on it. Do some like flexes.
Oh, you should be able to move the camera to whiteboard.
What do you mean?
There's a preset.
Oh, we had some issue with the speaker, and then we just unplugged it.
Oh, because
For
the
now.
speaker was on? Perfect.
Yeah,
Sorry, I
yeah.
missed that last
No,
night.
it's fine.
Yeah, great. And yeah, I was moving from Morana. I moved. Where did I put the whiteboard? I feel like I put it by the TV almost, and it like covered this.
Yeah.
This isn't the bad. We can also like somehow, and I forget how.
I was just doing before the break. I was doing this one, and I had it just like
Great.
angled a bit
That
more, but
that works. There is a way that like we can adjust where it goes right now.
yeah.
But somebody showed me a really long time ago, and now I forgot how to do it. I'm pretty sure you go. Let's try like in your face, or let's do the whiteboard actually. Sorry.
This one.
Yeah. And then go whiteboard cropped. Is that what it is? Yeah. Double click that. Configure video maybe. Okay, so this is where it gets. Shit, I don't want to fuck with this.
Yeah, it's okay for now. I can
Okay.
I can do this. I'll figure.
Sounds good. Nima knows
Yeah.
how I think,
Yeah.
or James does, so
Cool.
we'll figure it out next week.
Cool.
I'm going to be putting together a troubleshooting doc as well.
Yeah.
At some point.
Yeah.
I get you.
How hard for final project?
Pretty easy. Well, if you there's a game engine called Phaser, and you want to see, I did an advanced lecture on it, and we built a single screen, like real basic platformer in like 1 2 hour period. I can show you what we built, and that'll give you an idea. But I shouldn't say like, sorry, I definitely shouldn't say really easy, because it's a lot of work in terms of building a good game and getting the art and assets and like gameplay and everything like that. But in terms of like, if you're thinking, oh, how do we code like the physics? How do we code like the thing moving and stuff like that? Using Phaser as a game engine will make that side of it really easy. Yeah.
Don't have to like.
Yeah. No. Yeah, that'd be really hard. But yeah, Phaser takes care of like a bunch of things. You can do animations with it, your physics. Most of game development happens in like your game loop. So every frame, it's accessing a certain set of code. So it makes the loops really easy. Loading, yeah, art, sounds, it makes that stuff not too bad. Like you do have to spend some time learning Phaser itself, which I mean shouldn't be too bad, but yeah, I would definitely say to go for it if that's something you're interested in. I'll show you. Yeah, when we're done, I'll show you the my material on it and the little game that we made. Okay, we're gonna get back started here. So the first most important correction, we were making Planetary Fortress and we were giving them orbital command functions. Planetary Fortresses can't do scans and mule drops. They only have cannons. So that's our fix there. But we're gonna run through kind of a scheme of inheritance or looking at prototypes, and at any point, if you guys have any questions, just throw up your hand, because I know this stuff can get a little confusing or a little twisted. I'm going to try and visually draw it out here. This one's small. I realized I walked back there, so I'm going to make it outright bigger from going forward. But basically, this is our root prototype. I just have that its constructor is the object constructor, and like it has some built-in functions. So to start off, we made this constructor that makes command centers. And this produces objects with these two properties. And we saw that. You can give it, let's just, oops, new. Okay. Yeah, we look at this, we see that it has two properties in it, and it's prototype is the command center prototype. This. But like I said earlier, one of the benefits of doing these constructors is that we can save on memory. So if every command center has a build SCV function, there's not going to be any different between them. The location will be different based on the object, but this function will not. So what we can do is we can move this outside, and instead of this being a property of each individual object, we can make it a property of the prototype. So we say for every command center, the prototype of that command center is going to have a function build SCV, which builds an SCV. So now if we refresh and we make a new command center and we look at that, we can say in the object itself, it only has the location property. But if we look in its prototype, we can see that it has this build SCV function. So right now, we have our root prototype, and then right below it we have the command center proto. And this object it inherits from the root prototype, but it has the one property that we've said, which is build SCV, and this is just like a function. So this is our command center prototype, and if we create a specific version, so this is, say, center, this is the one that we made. This is an object itself, and this just has a location of some number. So this is our structure right now, which is nice. Every command center that we have will only have reference to this one function, but the unique data will be stored locally. So that's good. So here's where it actually gets useful. We are creating a second constructor called Planetary Fortress, and we want this Planetary Fortress to also be able to make SCVs and also have a location. And we want to give it a new functionality of its cannons. So this is where we went kind of wrong before. We want to set Planetary Fortress, its prototype, to an instance of Command Center's prototype. So before we didn't add anything to Command Center's prototype. So we had this pattern where we had a Planetary Fortress prototype pointing to our Command Center's prototype, but this was empty because we didn't put this function in there. So it was kind of useless. But now our Planetary Fortress will inherit this function from our Command Center, and our Planetary Fortress prototype is currently, it will have that build SCV. And then any specific Planetary Fortress that we make will be an instance of that. So let's look at how that actually works. So if I make a new planetary fortress and we look at it, we see that this particular instance of the object has our cannons function, because we've declared it here. And we see that its prototype is a command center. Wait, let's get rid of this. So here we're saying create a version of the command center prototype. The command center prototype is blank. And here we're adding an additional thing to it. So if we want this thing, we have to just use this version of it. Let's just double check. Yeah. So instead of creating a new command center prototype, we want to use the existing command center prototype. And now we should see our base planetary fortress has cannons, and its prototype has the build SCV thing. So it has both functionalities because it's inheriting from this prototype. But we don't see this location anywhere. So location is something that we want in our planetary fortress, but it's unique to each object, so we can't put it in the prototype because the prototype is shared by all of the objects. If we put location here, then every command center, and by extension, every planetary fortress that we make will have the same location. Or like if we make a new one, we'll like be resetting the location. So it needs to be stored here. And because our planetary fortress inherits from this, and it doesn't know about this, it will not have location. So in order to solve that, we have to go into planetary fortress, and we have to go, let's see. We want to go command center dot call. So we're calling the constructor command center, and we need to give it a context, and we can give it parameters. So what we're saying here is run this function, this constructor function. Instead of having this equal anything else, this will now be the current context inside of here. So this will refer to the planetary fortress object that we're making and any parameters. So it does take one parameter, so we're adding that too. So inside command center, when this is run, this will refer to the planetary fortress that is being created, and it will set a new location for us. Save that. Refresh this. So now we see our planetary fortress has a location, and oh, we didn't give it a real thing. Yeah, so now we see our planetary fortress has a location. It has its cannons function, and then in its parent, we see that there's the build SCV function. So this is nice. We have a kind of single chain of inheritance, but we can also do different patterns. So in StarCraft, we also have, let's copy this. We also have orbital commands, and they have the scans. So the same thing, we're building a new object. We want to use command center's constructor to set location, and then we're adding a new function of this scan. And then we want to set the orbital commands prototype to the command center's prototype. So we have our planetary fortress, and then if we make a orbital command, you see these two objects, both with different local properties. With location 20, this one has a scan. But the prototype for both of them will be the same. So this prototype is our command center prototype. It has build SCV. This prototype is the command center prototype, and it has the build SCV. So now we have one base set of behavior, and we have two different kind of types. Actually, our diagram is bigger now, so we have like three different types of types, I guess. We have our, I'm just going to say OC proto. This one has a scan. So we can make basic command centers, we can make planetary fortresses, and we can make orbital commands, each with kind of different set of properties depending on what they can do. Any questions on that pattern so far? Yeah. Here? Yeah, so what I should have done is we should take a location here. Location here. Now we can dynamically set them. And when it's when we're doing this pattern, it's adding it to the object itself. So this will have location. And that's how we want it again, because if we're doing it in a prototype or something, then it's shared by all of them. But that's a good point. So if we run the same things, but we give it, like this one gets 80. And then our fortress gets 90. If we look at this guy, we see his location's 80. And if we look at this guy, we have location 90. And then we could also just create a basic one, and we see that this one has a location of 30. So we have our three different types of objects that we could make. We have one of each right now. We could make 20 of each. We could, we have a lot of flexibility in how we want to make each one. We are saving memory because our function is being declared in one place. We're not having to repeat this function in different places or this location stuff. And for each individual one of these that we make, we're not having to redefine it. Any other questions on prototypes or inheritance or?
At a job, would we use this prototype way or the class way?
It depends. People can be very opinionated one way or the other. So some people really like the thing in JavaScript is that classes are built on top of prototypes and objects. So even though you're using different syntax, behind the scenes, JavaScript is using, something like this to kind of accomplish all of that. Although that doesn't mean that isn't a good way of doing it, because the class syntax is a lot more straightforward in some ways, especially if you're working with a team of like multidisciplinary people who come from backgrounds of other object-oriented programming. Prototypes will be very foreign to them. Class structure, class syntax is very common and is similar throughout all of the object-oriented languages. So in those types of teams, a lot of people will use this. For other cases, some people like the traditional. And also, if you're going smaller scale, there's like kind of small things that you can do with prototypes and objects where you don't have to commit to making a big class or things like that. Yeah, like whether you'll be using one or the other kind of depends on the team. React, as you've seen, uses classes. So if you're going to be doing a lot of React development, you're probably going to be using more of the class syntax, even if you're making your own classes and things. Yeah. Cool. Yeah, if there's any questions after this or anything, feel free to come up and ask me. I'll be posting this code and stuff online. There's a couple like bonus things I'll just go over like quickly. So if we're wanting to override a parent's method, so in this case we didn't have to, but say in our orbital command we didn't want to use the build SCV, we wanted to like change it. You could go this dot build SCV, and you can make it equal a new function. And because like we discussed earlier, when an object is looking for its property, it starts off locally and kind of circles bigger and bigger. So if we're looking down here at this instance of an object, it's going to look for its properties here, and then it's going to check in its immediate prototype. And if it's not there, it's going to move up, and it continues that pattern until it reaches the root. But it'll run the first instance it finds. So if build SCV is defined here, it'll just run that version. It's not going to look up here and find it. It'll just run the most local one. So if you're adding hierarchies and you're wanting to overwrite some functionality, you can use this. The other thing that might come in handy is extending. So maybe we say, well, I like the original functionality of build SCV, but I want to add like something additional to it. Similar to how we use this pattern here. We can say run the original function, which is in command center's prototype, except give it this context, and we don't need any parameters in this one because this function doesn't take any. And then we can add something to the bottom. So now if we build one of these guys, and we go orbital command dot build SCV, dot build SCV. We get the original functionality of the function and anything additional that we've added. So we can extend it, we can overwrite it completely. There's different things that we can do. But just here we're saying that build SCV function is in the prototype. We're calling it using this call keyword. And with this call keyword, we take two parameters, which is the context of this. We're setting it to the local this, and the parameters that we're passing to that function, which is nothing because we don't need anything here. Cool. Thanks, guys. Again, any questions, come ask. I know this stuff can get a little weird.